Which of the following numbers is a perfect square? Okay, so I noticed that all of the numbers here are in the following form. It goes n factorial times n plus 1 factorial over 2. So I'm going to rewrite that expression. That expression is the same thing as n factorial times n factorial, which is n factorial squared, and now just times n plus 1 over 2, which is now equal to n factorial squared times n plus 1 over 2. So this problem boils down to, if I can show that n plus 1 over 2 is a perfect square, then I know that the whole term is a perfect square. So I need to show this is a perfect square. Okay. So if I look at all the n plus 1 terms, I see, so if I have 15 over 2, here n is 14, 15 over 2, obviously that's then not going to be a perfect square because 2 does not divide 15. So basically all of the situations where n plus 1 is an odd number, it's not going to work. Then if I look at 16, so if I do 16 over 2, that equals 8. I know 8 is not a perfect square. The only one remaining is 17 factorial, 18 factorial. If I do 18 divided by 2, that equals 9. That is a perfect square. 9 equals 3 squared. So notice the final form that I'm going to write this in. Basically, I can write it down as 17 factorial, 18 factorial over 2. That is equal to 17 factorial squared times now 18 over 2, which is the same thing as 9, which is the same thing as 3 squared. So notice that 3 times 17 factorial squared. It can be written like that, and this is obviously a perfect square. So the answer is D.